The EdiLus software also contains the Masonry module, in order to manage new or existing masonry structures, so when we open a new document we can choose as a type of building, masonry or reinforced masonry. In the case of a new project, the choice can be either. In the case of an existing project, the choice can be only ordinary masonry. Let's suppose we want to create an existing masonry file. The software needs to know if the file represents the current situation or the design stage. Normally we start with the modeling of the current situation, and when the evaluation is completed, the file is saved and closed. At this point we start a new project, opening a new file, specifying that represents the current situation. Nobody forbids us, as in this case, for example, to hypothesize a modeling starting from the design stage. We access the EdiLus modeling environment. Normally when we start a project, the first operation is to import a CAD file. So we select the scale factor, and this model will serve as a reference for modeling. Within the parametric objects of the software, we find elements dedicated to the design of masonry walls. When we select the wall element, in the toolbox, we have the possibility to define the thickness and the type of material. The modeling is performed as we have already seen, in an intuitive and friendly way using the information of the CAD model. With regard to the properties of the materials, the software needs to know if we are dealing with a design stage or a current situation element. It is worth paying particular attention to the type of material. When we associate a material with the wall, it is assumed that this material has been previously uploaded to the material library. The choice of materials is often related to the table of characteristics of this material. However, you must set the level of knowledge within the calculation preferences, in the existing buildings section. This is necessary because the table of the material properties fixes the average resistance of the materials based on the level of knowledge. Once the level of knowledge has been defined, we access the materials archive, in the masonry folder, and by right-clicking we add a new masonry material. We can freely decide the physical and mechanical characteristics of the masonry, or even, as we had already anticipated, we can refer to the predefined tables. Once all the physical and mechanical characteristics of the material have been defined, this wall template is loaded into the masonry archive. Once the material has been defined, we can return to the plan level. Here we can associate the newly created material with the wall we had designed before. Once this has been achieved, we can continue with modeling. The software also offers us this possibility, by activating the appropriate function, to be able to carry out automatic recognition from the CAD file. So it is enough to create a small transversal line, and in this case it will be the program that automatically reads the wall thickness. When designing a walls, we can notice a construction line with a greater thickness. This indicates a fixed line. For example, if we copy this wall to other levels, the reference will be the line with the greatest thickness. You can also change this alignment. For this you just need to select the desired elements, and in the right side properties panel, we find the alignment option. In this way we can change the alignments of the selected walls, so that in a repetition of these walls that can be performed in the upper floors it will be done with a center alignment. This is the plan representation of the perimeter of the wall. If we access the 3D view to see how our model is presented, we can have the opportunity to open both the 3D view and level plan windows. At this point we can access the management of the levels, and we will add other levels. Let's see how the modeling can progress in the other levels. We access the first floor and activate the background in order to display the trace of the walls of the lower floor. This track will serve as a reference to model our structure upon the plan. We can also work much easier and more comfortably using the copy and paste function. To do this we have to make a multiple selection of all the elements. But, as we have already designed this wall, we can deselect it. We will deselect these other walls in the center as they will not be present on the next floor, and we will also deselect the background. Now, thanks to the copy function, only the selected entities will be pasted on the top floor. So with a really simple and fast operation, we have the model of the structure also on the upper floor. In this area where we haven't copied the walls, we will build a reinforced concrete structure. We select these walls and activate the upper edge beam option. In this way, the software recognizes that these walls will have a beam at the top. Once the option is activated, we simply have to size the beam and its reinforcement. To complete the model, we add the reinforced concrete structure to the first floor. Select from the Design menu the Parametric Object column. In the Properties, we must indicate the design stage condition for this column, being a newly built element. We insert the column in the level plan, and using the handle we define its alignment. Over these columns we will insert a beam that will also be a design stage object. Let's go back to the 3D view to have a global view of the model. Subsequently, we begin to add loads, such as floors, in this case a reinforced concrete floor. The software offers us several other possibilities, such as for example the steel floor. Among the loads we can also choose the vaults, such as the barrel vault for example. These objects will behave as loads within the calculation. They are considered vertical and horizontal forces on the wall. Directly from the 3D environment, we see that it is possible to activate a view of the materials. For this, we simply have to click the button, Show Texture. This view is particularly useful, as it allows us to quickly and unequivocally differentiate the walls. Imagine that we have to demolish these walls, so we have to specify that these are project walls. We will change the type of material, such as choosing a new wall in concrete blocks. Let's see how graphically we can distinguish the new walls from the wall already present in the project. We complete our model, adding some particularly important objects for masonry constructions, the apertures. These are not just holes, because when we model an opening, each element contains different properties. As we can see in the opening object, we can assign a reinforced contour or a reveal. We can characterize the object geometrically, giving it a height and a base distance. We can also indicate if we want to apply to this opening a lintel that can be of reinforced concrete or even of steel. We can take advantage of automatic generation of the object from CAD files, so that the length of the opening is directly visible from the model. Thanks to this option, it is really easy to model the openings. If we are going to model the doors, we simply need to change the geometry of the opening. To this opening we apply a reinforced concrete contour, while to these openings we apply the reveal in solid bricks. Now we begin to recognize, graphic point of view, that our model is characterized locally by different types of materials. So when we check the structural model, we'll see how the software will identify them and recognize these elements with different physical and mechanical characteristics. Within our model, we may also need to perform an intervention, which is why the software has the patch object. Within the properties table we have the possibility to freely design this element. Once modeled, we associate a material. In this way the software will consider a basic masonry wall, with locally another type of material. It is also possible to apply reinforcement to our model. These reinforcements can be added locally or on the entire wall. When we create a masonry model, we have to carry out global checks of the entire building. We also have to carry out local checks. As for these checks, a really important object is the chain, which we can add directly from the plant to the model. To obtain the local checks, it is necessary to apply an object directly from the plan view, called facade, calculation section. Once the object has been inserted in the plan, it is automatically applied on the entire facade. This is calculated by considering the bending and tipping data.